Here's another example of a complex fraction. This is problem 31 from the Chapter 6 review. We want to find a multiplier that can cancel the denominators that are in these two fractions that are within the overall complex fraction. Remember, that's what makes a fraction a complex fraction. We have a fraction that contains fractions in its numerator and or denominator. And our plan of attack that we've been using is to find a multiplier which would cancel the denominators of the fractions within the overall fraction. That will at least give us one step towards making a simpler fraction. In this case, that multiplier needs to be x plus 3. I'm going to take the binomial x plus 3 and multiply it times both of the terms that are here in the numerator, and multiply that entire binomial times both of the terms that are in the denominator. When we multiply this binomial times the 3, we would end up having 3x plus 9, right? 3 times x is 3x, 3 times plus 3 is plus 9. And when I multiply this binomial times the fraction 1 over x plus 3, the x plus 3's will cancel, simply leaving me minus 1. Same thing here in the denominator. 3 times the binomial x plus 3 will give me 3x plus 9. 3 times this fraction, the x plus 3's will cancel, leaving me plus 1. Remember, I can't cancel those 3x's, I can't cancel those 9's, and again, that's because they're tied up. Those are terms that are tied up in additions, and in this case, a subtraction. We can only cancel when there's multiplication between quantities. Then canceling is possible. So we would simply need to combine the like terms. So we have 3x plus 8 in the numerator, 3x plus 10 in the denominator. Again, the 3x's cannot be canceled because they are tied up with addition. And that's as simple as we can make this fraction. But again, that fraction is much less complicated than the original one. If we were to have to do further work with this fraction, it would be much easier to work with it in this form than in the original form.